Chapter 4 material. Okay, chapter 4 metals and the non-metals. Okay, so the occurrence of the metals and the non-metals. So the out of the 92 naturally occurring elements, the 70 are the metals and the 22 are the non-metals. So the some metals shows the properties of both the metals and the non-metals, so that we call it as a metalloids. In some of the behavior they will show the metals character, and some of the behavior they will show the non-metal character, so that we call it as a metalloids. But only some metals like the gold, silver, platinum, so these are all we call it as a precious metals, so which found in the free state. Free state means it is not combined with any other atom. Say for example oxide, oxygen, chlorine, so then sulfur. So it will not combine with any other non-metal. It exists as the metallic state as such. So just with impurities it will be present. Impurities such as the sand, that's all, because we are getting it from the earth crust, right? So it contains only the sand as the impurities. The most metals are found in the combined states as the oxides, sulfides, carbonates, silicates, etc. So some of the nonmetals are found in the free state like helium, neon, argon. So these are all we call it as a noble gases. So the noble gases are unreactive in nature. So they always exist as a single atom because their outermost electronic valence shells are completely filled by the 8 electrons. So they do not combine with any other atom. And some of the found in free and the combined states like sulfur, phosphorus. So these two things, the sulfur and the phosphorus, it will combine with the same atoms. So and it forms the S8 and the P4. But it will not combine with any other atom. Metallurgy. So the metallurgy is nothing but how we can able to extract the metals from the ores and the purification. So the ores is nothing but the abundance of there are so many, say for example aluminum is present in aluminum chloride, aluminum oxide and all. But we in the aluminum oxide the composition of the percentage composition of the aluminum is very high. So that we call it as the ore. The natural abundance, the percentage of mass of the metal should be very high. Then only we can able to extract the more metals. So that we call it as a ore. And how we are extracting the metals from the its ore. Suppose aluminum oxide is there. How we are extracting aluminum from the aluminum oxide. So we have to think it of how to remove the oxygen from the aluminum. So that we call it as a extraction of metals from the ores. So after that we need to do the purification because we need to get at least 99.9 percentage of the purity of the metal. Minerals. The minerals are nothing but it's naturally occurring the substances it contains one or more elements or the compounds. Ore is the mineral which forms one or more metals can be extracted profitably. Yes, we should think about the profit. So because the extraction needs a lots of cost as well as the energy. So we have to choose a ore in which the whatever the metal we are extracting that should be very high composition. Metallurgical processes. So it consists of the three steps basically. One is the concentration of the ore, and second one is the reduction, and third one is the refining. The concentration of the ore is nothing but we have to remove the impurities from the ore. So we are segregating the ore from the impurities. Impurities are nothing but the sand. Reduction. So the reduction is nothing but, so it's a process of obtaining metal from the compound. So usually we have to use the carbon or the carbon monoxide to remove the oxygen from the ore. Then we can able to extract the metal. Refining. Refining is nothing but the purification of the impure metals to get the pure metal. Physical properties of the metals and non-metals. So the physical properties are nothing but, so how it's looking by physically, what is the color, density, melting point, boiling point. So those stuffs we call it as the physical properties. So metals. The metals are usually solids except mercury. So mercury is one exception which exists in a liquid state at room temperature. The non-metals may be solids, liquids or gases. So for the solids, example carbon, liquids is a bromine. Bromine exists as a liquid at room temperature. Gas, nitrogen, oxygen, neon, helium. So these all the stuffs exist as a gases. But why metals always exist as the solid? But why not the non-metals? Most of the non-metals exist as the gas because the metals having a electrostatic attraction between the positively charged metal ions and the delocalized electrons. There is a strong force of attraction is there. That's why it exists as a solid at room temperature. But in the non-metals, usually it forms the covalent compounds. The covalent compounds are formed by the sharing of the electrons, that is just very weak bonding compared to that of the ionic, say, present in the metals. The metals are usually hard except the sodium, potassium, etc. So the sodium, potassium are present in the group 1. So these metals can easily cut with a knife. But say for example iron, nickel and all, it's a very hard metal. So usually the metals are always hard. The non-metals which are solids or brittle. So say for example carbon is very brittle. The only one exception is the diamond. So diamond is the allotrope of the carbon. It is one of the hardest substances in the world. Metals have the metallic luster. Non-metals do not have the luster. Some have the double luster. Luster means the look. It's having a shiny look. The finishing itself is very good in this. But the non-metals are always having a dull one. So if you take the carbon, it's a very blacky appearance is there. So it's not like shiny appearance. So that we call it as a luster. The metals have the high melting points and the boiling points. Yes, because due to the strong attraction between the positively charged metal ions and the free electrons. Here the nonmetals have the low melting points. That is why it exists as a gas at a room temperature. The metals are malleable. Malleable means we can able to convert that into the sheets, copper sheets, aluminum sheets. So we can able to convert into the thin sheets or thick sheets, whatever we want. The same way we can able to do it. So it means that it's can able to flexible. We can do it. But the non-metals are not malleable because it exists as a gas. Most of the non-metals exist as a gas. We cannot make that into the sheets. Metals are ductile. Ductile is nothing but a wire. So copper wire and the aluminum wire. So these are all the wires we can able to make it. So because it's so flexible, they are arranged in the layer form. That's why. So when you want to make that one, so it slide over each other. The metal atoms are slide over each other. That is why it is so easily flexible, and you can able to make whatever the shape you want. So the non-metals are not ductile, so you cannot convert into the wire form. The metals are the good conductors of heat and the electricity. Okay, how the metals can able to conduct the heat and electricity in the solid state? Because the metals have the free electrons in the structure. That's why it can able to conduct the electricity. The non-metals are the bad conductors of the heat and electricity except the graphite. Okay, so graphite is the only non-metal which can able to conduct electricity because the arrangement of the carbon atom is such a way that three carbon atoms are bonded to one another. So the one electron on the carbon is set free. So that electron is can able to conduct the electricity. The metals or the sonorous. Sonorous is nothing but it can able to produce the sound. The non-metals are not sonorous. So the non-metals is always exist as a gas only. So if it is a carbon and all of your this one it's so brittle it cannot able to make a sound because it's not that much hard as well as the density. Chemical properties of the metals and the non-metals. So the chemical properties are nothing but how the it is reacting it with the other elements. Say for example oxygen, water. So whether it can able to react or not, it cannot able to produce. So that we call it as a chemical properties, how they are reacting it with other stuff. Reaction with oxygen. So usually the reaction with oxygen is nothing but we call it as a combustion reaction. So the metals react with oxygen to form the metallic oxides. So these oxides are basic oxides because they react with water to form the base. So example, when the magnesium Mg, when we are treating it with the O2, so we will be getting MgO, magnesium oxide. So how do you say that it's a basic means? This magnesium oxide we have to dissolve in the water, so it will produce as the MgOH twice. So when it will dissociate into the Mg2 plus and the OH minus. The compound which can able to give the OH minus, we call it as a base. So in this case MgO is also the base. The nonmetals react with the oxygen to form the non-metallic oxides. So these oxides are acidic in nature. The same way we have to test the produced oxide that we have to dissolve in the water. So when react with the water to form the acids. Example, so the sulfur we have taken. Sulfur is the non-metal plus O2, it's giving SO2. So when we are dissolving in the water, so we will be getting H2SO3. It is sulfurous acid. So SO2 is the acidic oxide. Next one is the reaction with water. The metals reacts with the water to form the metallic hydroxides and the hydrogen gas. Okay, so now Na is there. When it reacts with the H2O, it forms the NaOH plus hydrogen gas. So how can we identify the hydrogen gases coming from the reaction? So it will give the bubbles. So from that we can able to identify the reaction is going on. So the hydrogen gas is releasing. So how can we test that only the hydrogen is coming? So when you are taking the wooden splint, so you will get the pop sound from that. So from that we can able to identify only the hydrogen gas is coming out from the reaction. The magnesium reacts with water to form the magnesium hydroxide and the hydrogen. Mg plus H2O gives MgOH twice plus H2. Okay, here it forms NaOH. Here it is MgOH twice. But why we are writing the 2 over here? Because Mg is present in the group 2. It's having a valency plus 2. OH is having the valency minus 1. So when we are doing the cross multiplication, so MgOH twice. So in this case, sodium is having a plus 1 charge, OH is having the minus 1 charge, so both gets cancel each other. So NaOH is the formula. So next one is the reaction with acids. So metals can able to react with the acids to form the metallic salts and the hydrogen. So the example zinc we have taken, when the zinc reacts with the dilute hydrochloric acid to form the zinc chloride and the hydrogen gas. So most of the non-metals, they do not react with the acids. Some non-metals like sulfur reacts with the concentrated nitric acid to form the sulfur dioxide, nitrogen dioxide and the water. So the sulfur reacts with nitric acid, forms the SO2, NO2 and the water. HNO3 is nothing but the nitric acid. Metals replace metals. Okay, so this we call it as a displacement reaction. So the displacement reaction is nothing but the one metal can able to displace the other. Displacement means, so if the one metal is having some anion, that it can able to take away from the particular metal, that we call it as a displacement. A more reactive metal replaces the less reactive metal from its salt. See, for example, the magnesium reacts with the copper sulfate. So now magnesium is the high reactive metal, and it reacts with the copper sulfate. So the magnesium, it replaces the places of the copper and it forms the magnesium sulfate plus copper. Next one is the zinc. The zinc reacts with the copper sulfate. So the in the place of the copper, the zinc will occupy. So the zinc sulfate plus copper. So this reaction can occur only if the only if the reactive metals can able to react with the less reactive salt. Otherwise, there will be a no reaction. So Fe plus CuSO4 gives FeSO4 plus Cu. So Fe is more reactive than the copper, so it can able to take the place of the copper and it forms the FeSO4 plus Cu. So based on the reactivity of the metals, they can be arranged in the decreasing order of their activity. So this is the activity series of the metals. So the first one, the arranging of the metals in the decreasing order of the reactivity is called the activity series of the metals. So the potassium is the first metal in this. So it's very highly reactive. Then comes to the sodium, then magnesium, then aluminium, then zinc, iron, lead, copper, silver, gold. So potassium is the high reactive metal. Gold is the least reactive metal. So in between the zinc, iron, lead and all, we call it as a moderate. It's a moderate reactivity metals. It's not that much more reactive or the least reactive. Moderately it will react. Noble metals. So the metals like the gold, silver, platinum retain their luster because they do not react with the air, water or the acids. So they are called the noble metals. The gold dissolves in the aqua regia. Aqua regia is the mixture of the concentrated nitric acid and the concentrated hydrochloric acid in the ratio 1:3. So the aqua regia is nothing but, so it's a solution, it contains only the nitric acid as well as the concentrated acid. So we have to take only the ratio 1 mole of the concentrated nitric acid and 3 moles of the hydrochloric acid. So the gold can able to dissolve in that. It's not reacting, it's just dissolving. So the pure is nothing but the 24 karat gold. So it is very soft and cannot be used for making the ornaments. Yes, so nowadays whatever we are using is the 916 kdm. So the 916 kdm is nothing but 91.6 percentage of gold is present in that particular ornament. So the remaining things they have to mix it with the copper or the silver to make it hard. Otherwise, the 24 karat gold is very soft. We cannot able to make any ornaments out of it. So uses of the metals. So as of now, we are using so many metals in our day-to-day life. One of the most used metal is the iron. So it is used for making pins, nails, nuts, bolts, tools, machines, the construction of the buildings, the bridges, etc. Aluminium. So the aluminium uses used for making utensils, wires, furniture, the parts of the aircraft, vehicles, machines, for packing the food and the medicines, etc. Because it is a very less dense metals, so we can use it for in the aircraft. Copper. So the copper is used for making the wires to conduct the electricity, vessels, the electric gadgets, etc. Gold. It is used for making the jewelry, coins, medals, etc. Silver. It is used for making the jewelry, coins, medals. Platinum. So platinum is also used for making a jewelry, electric gadgets and plugs in vehicles, etc. because it is very inert. So that is why they do not react with any other atoms. So that's why they are using in the plugs and as well as in the electric gadgets. Sodium. So the sodium as compounds are used as a common salt. Yes, the whatever the salt we are using in our day-to-day life for the food is nothing but the sodium chloride and used to make some of the chemicals from the sodium. Calcium. Calcium compounds are used for making the cement, glass, etc. Uses of the non-metals. So sulfur. Sulfur is used for making the sulfuric acid, salts of the metals, etc. Oxygen. It is used for the respiration by living things, burning of the fuels, etc. Nitrogen. It is used for making the ammonia, yes, NH3, one of the important reaction, so which is used for making the fertilizers. Hydrogen, it is used for making the ammonia, which is used for making the fertilizers as fuel in the rockets. Why we are using the hydrogen in the rocket means because it is a very lightweight, lightweight fuel, that's why. And also it is very less dense, so the rocket can move in the upward direction. That is also one of the use in the hydrogen gas. Chlorine, it is used to kill germs in the water. Iodine, it is used as a tincture iodine, which is an antiseptic. Alloys. Okay, the alloys are nothing but it is the mixture of the metals with the metal or the non-metal. So the first one is the steel. So steel contains the iron and some percentage of the carbon. So it is used in the construction of the tools, machines, tanks, vehicles, ships, rails, building, bridges, dams, etc. Stainless steel. So stainless steel contains the iron and the chromium. So uses utensils, cutlery, surgical instruments, etc. Brass. So the brass is combination of the copper and the zinc. So it is used for making the utensils, handicrafts, musical instruments, etc. Bronze, copper and the tin. It is used for making the statues, medals, bells, ornaments, etc. Alnico, it contains iron, aluminium, nickel, cobalt. So making of the magnets. Duralium, aluminium, copper, magnesium, manganese. Making the utensils, pressure cookers, parts of the vehicles, aircraft, etc. Corrosion. Okay, so the corrosion is mostly shown by the iron because it will undergo oxidation easily. The two in the presence of the moisture only the corrosion takes place. So in the presence of the water as well as oxygen will make the corrosion more. Suppose in the presence of the salt water contains the sodium chloride, so it will aggravate the rate of the reaction, so the corrosion will occur very fast. So it is nothing but the metal gets corroded when exposed to moist air for a longer time. It is not a one day, 2 day process. It's just years together. So 2 years or 1 year depends upon the exposure of the iron to the air as well as the moisture. So this we call it as a corrosion. So how can we prevent the corrosion? So by applying the oil or the grease and applying the paint. Galvanization. Galvanization is nothing but the coating of the metals with non-corrosive metals like the zinc. So what will happen? We can able to protect the iron from it. But the zinc will undergo the oxidation. Electroplating. Electroplating is nothing but the coating of the metals with non-corrosive metals like chromium, tin by passing the electricity. Alloying. Alloying is example when iron is alloyed with the chromium and the nickel, it forms a stainless steel, so which is resistant to the corrosion. Otherwise, if only the iron and carbon is present, easily it will corrode. So, okay, activity to show that the air and the water are the necessary for the rusting of the air. Okay, so now we have taken the three test tubes. So we have put one iron nail in the each. Okay. So in the first one, some anhydrous calcium chloride we have put it. So why we have put the calcium chloride over here is it will absorb the moisture from the air. Okay. The second one is pour some boiled water from which the dissolved oxygen has been removed. So we have, in this case, the water we have removed it because by using the calcium chloride. In this case, we have removed the oxygen. So in this, the last one, pour some water in the third test tube. Then we have placed the cork and leave it for the 3 to 4 days. Then after that, we are seeing that the first test tube and the second test tube have not rusted at all. But the nail in the third test has rusted. So it means that the oxygen as well as the water both are necessary for the metal to get corrode.